Imagine waking up from a coma, suspended in a dark, silent room. You have no memory of how you got there or even your own name. You are completely isolated. Slowly, the reality of the situation returns. The sun is being eaten by a mysterious infection. If you cannot solve the crisis alone, everyone on Earth will freeze to death in a global ice age. This is the exact situation facing Ryland Grace, the protagonist of Andy Weir's novel Project Hail Mary. But Weir discards the dogfights and warp drives of typical sci-fi. Instead, his hero has to fight the actual, unyielding laws of physics. Surviving a trip to another star is a brutal, unforgiving mathematical puzzle, where the real universe proves to be far deadlier than fiction. To understand why interstellar travel is so difficult, we have to look at the sheer distance. Even our nearest neighboring stars are trillions of miles away, and getting a spacecraft there requires a massive amount of fuel. The Tsiolkovsky-Rossett equation dictates a cruel paradox. Fuel is heavy. To move it, you pack extra fuel to push the first batch. To reach a star in a human lifetime, your chemical rocket needs a fuel tank larger than the entire observable universe. To solve this impossible equation, Weir introduces astrophage. It's an alien microbe that functions like a cosmic mold, feeding directly on starlight. It absorbs that radiant energy and converts it into physical mass, packing an incomprehensible amount of power into a microscopic space. To cross light years, humanity has to weaponize the very plague eating the sun, repurposing that starlight consumption into the energy density required for interstellar transit. In movies, ships routinely zip through the galaxy at light speed without a second thought. Accelerating a physical object to those velocities in the real world comes with horrifying consequences. We tend to think of space as an empty vacuum. It isn't. The interstellar medium is scattered with dispersed hydrogen atoms. At normal speeds, these atoms bounce off a hole harmlessly. Accelerating near light speed turns static atoms into cosmic space mines. Striking with immense kinetic force, they transform into intense ionizing radiation, instantly melting the ship. This unyielding radiation barrier limits the absolute maximum safe speed for any vessel to half the speed of light. The faster a crew tries to cross the universe, the harder the universe tries to tear their ship apart. But even if the ship survives the journey, the human body is a terrible vessel for space travel. Prolonged exposure to microgravity rapidly breaks down our carefully evolved physiological systems. Right off the bat, astronauts suffer from space adaptation syndrome. Without gravitational cues, what your eyes see completely mismatches what your internal balance organs feel, leading to debilitating disorientation. Then there is the long-term damage. This image shows a real astronaut conducting an in-flight vision test on the International Space Station to monitor for vision impairment intracranial pressure, or VIIP. The fluid shifts caused by microgravity literally flatten the back of the eyeball and swell the optic nerve, permanently degrading their sight. Compare our fragile Earth-dependent biology to Rocky, the extraterrestrial engineer from the planet Erid that Grace encounters. Real exobiology doesn't look like an actor wearing a rubber face. Erid is a massive planet with crushing gravity and a completely pitch-black, high-pressure atmosphere, so Rocky evolved as a blind, ammonia-breathing, spider-like creature with an exoskeleton made of rock-like minerals, using echolocation to observe his environment. If humanity ever does make first contact, we won't be shaking hands with a humanoid. We'll be trying to communicate with a radically divergent organism, forged by the brutal mathematical realities of an entirely different world. Author Andy Weir derived the travel times and fuel loads for the Hail Mary through specific datasets and relativistic equations. Weir wrote a custom software simulator to model the ship's trajectory, accounting for relativistic time dilation and precise orbital mechanics across the entire journey. That level of rigorous mathematical dedication shows us something important. The real universe, bound by absolute physical laws, is vastly more compelling than standard sci-fi fantasy. Exiting the solar system is a one-way flight, where physics actively erodes the human frame. It is a mission of total isolation, where the distance alone ensures the crew will never return home. Between the lethal radiation limits and the physical breakdown of the human body, The reality of the trip is clear. If you were selected for a one-way flight to save the planet, would you accept the mission? Sound off in the comments.